Hello friends, this is the third part of our video concerning the laws of motion. In the first two parts we studied about the constraint on string and wedge constraint and some small questions we discussed. In this session I will be discussing about the forces, because once you are familiar with the force session, then we can move ahead with the laws of motion. So the basic introduction of the force, as we know, it is a push or pull. It is a push or pull. This two term plays significant role in identifying the various type of forces that is existing. As we know, it is a vector quantity. It is a vector quantity. To know the scalar and vector quantities, we have another video. You can move there to get the physical parameters types, that is vector and scalar. And the third point is its SI unit. Its SI unit is Newton, named after the great scientist Sir Isaac Newton, mentioned as capital N. One point should be remembered that whenever there is a unit kept on the name of any scientist, the first letter is taken, and that too in capital. For example, if I am taking the unit of work, you know that the unit of work is joule. So every time we will write joule as small j. No, small j we will not write, but we will write it as capital J. This is the representation method. So this is a very basic thing about the unit and dimension. So this is overall about the basic introduction of forces. Now this force has been divided in two parts. As we know, this is contact force and another one is non-contact force. Contact force means the two bodies in contact. Suppose this is a block and this is another block. I am keeping one block on this one. So the two blocks are in contact. So the two blocks are in contact. It means the forces that will be acting between them will be a contact force. For example, if I am taking the person standing on the ground. The person standing on the ground, it means this person is applying the force on the ground and ground is also applying on the force. When they are applying, when the both two are in contact. But if I am taking about the non-contact force, it means the force still acts even if the bodies are not in contact. For example, I will be taking the example as electrostatic force, which is as we know Q1 Q2 upon R square, where Q1 is one charge, Q2 is another charge, separated by distance R. What we see here, this electrostatic force can be of attractive as well as of repulsive nature, depending upon the nature of charges. The force is still acting even if the two charges are not in contact. Similar way, another example of non-contact force is gravitational force. The two blocks of mass m1 and m2 separated by some distance d, again having the force of attraction between the two blocks, and this is F gravitational, and this is F magnetic force, again between the two magnets, that has some value which we will be studying in further classes. So based on this contact and non-contact force, finally the force which we have to study has to be divided in various types, and these types are categorized based on contact and non-contact force. The first one is mechanical force. Second one, gravitational force. Third one is electrostatic force. Fourth one is magnetic force, and last one is nuclear force. Out of the following categorization, this mechanical force, gravitational force, electrostatic force, magnetic force and nuclear force, we will be studying here only this mechanical force section. This gravitational force will be studied in gravitation chapter, electrostatic in further, magnetic in another chapter, and nuclear force in modern physics. So this mechanical force are categorized again in following ways. Like the first one is string force. String force, as we have already aware of the string concept, so now we will be applying the string forces in different block system. The next one is normal contact force. Third one is force on spring, or it is also known as spring force. And the last one is frictional force. Frictional force. The whole four forces we will be discussing in this chapter. Small introduction, and again after the small basic introduction of all the forces, this friction I will be explaining in further videos, but this first three forces will be dealt on here only. Once we are aware of the basic implementation of this type of forces, we will be moving on Newton's laws of motion. So I am starting with the string force. So the first one is string force. As we have already studied in the force definition, that force is out of push or pull. So the force can have the tendency to push or pull only. Now you take the string. Suppose this block is attached to the string. This is block mass m attached to the string. The string is connected with the mass m. Now you see this, of course, if this mass is hanging, it means definitely this string is putting force on this block mass m. In further stage I will be discussing the free body diagrams when Newton's law is coming, but here my intention is only to make you familiar with the direction of the forces. So now if you take this string, how this string will be acting the force on the block? Very simple thing you need to identify, that this string force is of pulling nature. You first remember this point, this pulling nature. It has always a tendency to pull out the blocks. For example, suppose this is the block attached. So what will be the intention of the string is to pull this block in its direction. This point will be pulled in this direction. So to easily identify the relation or the direction of the tension force, or I should say this string force, I should make one point here, is also known as tension force. To identify easily the direction of the tension force or string force, you generally try to identify the center of the string. And if you look out here, center of the string is like this point, and every time whenever the force by the string will be acting along the direction of the center point. It means this point will be acting the force on this block in this direction, and this force will be acting the force on this point in this direction. So the string force will have always the tendency to in the direction to the midpoint of the string. This is what the basic, or I should say in simple pattern I should say. For example, again I am taking, suppose this is one block, I am taking one more example here. Since this is one block and this is string connected to this one is m1, this one is m2. I am asking the direction of the tension force, how it will act. Leave all these parameters, what will happen, but I am just simply concerned about the tension force. So what this point will be having some tension, this point will be having some tension. Again, now the very important thing is you need to just find out the center of the string. Somewhere it will be lying here. Now this tension force will always act along the direction of the center. It means this direction in this, and this while having this direction. This is how we easily identify the direction of the tension force. Remember the 2 to 3 points which is very clear. The first point is the tension force is of pulling nature. To identify the direction of the tension force, we take the center of the string, and center or the direction of the force, tension force will be along the center of the string, So now we can easily identify the direction. I will show you with examples also. And one more thing is very important to know here, that if string is same, it means if two different strings are not there, if there is no any node in the string, it means tension throughout the string will remain same. This is very important point. Again I am repeating that tension force throughout the string remains same unless there is a node in the string or two different strings are attached. For example, let me first write all these things, that if the string is same, then the tension force remains same throughout the string. Next point, I will be sharing this again. Next point, it is an internal force. Now, I will take one more example. Suppose this is a pulley block system, as we are already aware. This is the one block attached and this one is another block attached. We are familiar with the velocity acceleration relations. This one is m1, this one is m2. Now if I am saying to identify the direction of the tension force, it means this string will have center somewhere here. So this force will be acting in this direction, and if I am saying about this point, I will action in this direction. Similarly, this string has center here, so it will have the tension in this direction, and it will have tension in this direction. Since whole string is same, so tension throughout the block system will be same. Next comes here the normal contact force. As you know, normal means perpendicular. Contact means two bodies are in contact. Those forces which acts between the two bodies in contact. For example, suppose this is a block kept on ground of mass m. So normal force acts in such a way that it is perpendicular to the common tangent of the point of contact. It means, for example, let me explain this in a proper way. This is the point of contact. So this is, if you draw the tangent on the point of contact, the tangent will be like this. So the normal force acts in this direction or in this direction, because I should say in simple manner that normal contact force always acts perpendicular to the common tangent on the point of contact. One important point we can easily identify, that this body apply force on this and this body apply normal contact force in this. So this has the push nature tendency. It means normal contact force is of pushing nature, Every point should be remembered, because these only are the basic parameters on which the laws of motion generally depends. One more example I will take. Suppose this is a block and there is one block attached on the corner side. So if I want to identify the direction of the normal contact force, so what will you do? We will draw the common tangent to the point of contact, and this common tangent will be like this, and perpendicular to the common tangent at the point means either in this direction or in this direction. So since this normal contact force is of pushing nature, so this block will push this M2 block in this direction, and M2 block will push M1 in this direction with some normal value, say some value N1 or N2. Well, N1 will be equal to N2. This is some another mathematical calculation that will be studied in Newton's laws. So we can easily identify the normal contact force acting between the two blocks. The next one is, once I am making you familiar with the different types of forces, after that, once we are starting the laws of motion, there we will have the detailed explanation of normal contact force acting over. The third point, this was the second point, the third point is the spring force. I will be sharing this normal contact force have some very important points, that every time as the definition is that it acts only when the two bodies are in contact. But when two bodies are in contact, it is not necessary to have a contact force. So all these things I will be discussing in laws of motion. So please remember the facts right now which I am discussing with you people. In further classes I will be showing that even if the body is not in contact, then also contact force, even if the bodies are in contact, then normal contact force may or may not work. Now third one is the spring force. And spring force, you know, we are very familiar with the spring. This is the spring and this is the one block attached. Suppose simply if you are keeping this spring, suppose this is a spring, if you are keeping the spring on the table, there is no any force, spring will remain as it is in the natural length. But the instant you just stretch out the spring or pull or push, you push or pull the spring, it has a tendency to regain its original shape. This is what about the spring force. So what say, if there is an external force acting on the spring, then there comes a force, and which force is proportional to the displacement. Suppose the block gets displaced by x unit, then the spring force is directly proportional to the x, the length displaced. This displacement can be extension or compression, because even if you compress, the spring has a tendency to regain its shape, or even if you extend, or it has a tendency to regain its original shape. So what is happening? Suppose we applied some external force here. So now what happening, this spring force starts acting in this direction. Why? Because it has a tendency to regain its shape. So this force and displacement, you see the spring force in this direction and x is in this direction, so there is, we'll put some minus sign. Why? Because always it opposes the displacement side. So while removing the proportionality constant, it is some minus k into x, where k is the spring constant. If I say about the spring constant, this is spring constant will be equal to some Fs by x. So its unit will be Newton per meter. Now if we so the final spring force is equal to minus some k into net elongation in the spring. I will be discussing all these things in a proper way. I will draw one simple graph here. You see the graph. This is, I should say, the y-axis. This is the x-axis. I am taking the force on y-axis and displacement x on x-axis. This direction is x. Now you see, if you are taking the x positive, then a spring force will be negative. If you take the x positive, then a spring force will be negative. So what does it mean? The force is positive in this direction and negative in this direction. So x positive means force is negative, so the direction will be this. Since it's the equation of straight line y equal to mx, so the graph will be passing through the origin. If we are taking the x negative, it means the force will be positive. So this is the overall graph of the spring force acting on the body. Corresponding point, easily we can identify this spring force only acts when there is some external force. So we can in parallel also draw the graph for external force with respect to displacement. So the force is external, force displacement is positive. When force is positive, it means this is the graph dotted. I am showing this with the red pen. This is the graph I am showing with the dotted pen. This is the graph for F external. So if f external, x is positive, x external is positive, x is negative, f external is negative. But when the x is positive, spring force becomes negative, and when x is negative, the spring force becomes positive. This is the overall of all the forces which we will be discussing, and frictional force we will be discussing in further section, because frictional force has different aspects, a different unit, a different complete package. So these all types of forces will be acting or will be implemented in laws of motion in the next videos.